All right, so 47, number 3C. All right, we're solving some logarithmic equations here. All righty, who's got an idea about 3C? It looks just like a couple that we did the other day, so you should be able to handle this. Anybody have an idea? How to start? Lawrence? I think that's a wonderful idea. So we can't move this until the logarithm is by itself. So we'll get rid of the 2.
We make it a positive 2. And negative 2. Like, we divide by -1. So,
Absolutely, you can. Now, I'm going to be dividing by -1 now, but if you want to divide by -1 in the beginning, you can. But you're right, this logarithm can't have anything in front of it, including a -1. So I'm going to divide now. And remember, when you divide, you're not changing any part of the logarithm, you're only changing that, getting rid of that. Is this okay with everybody?
Why don't you change that? Oh wait, because it's attached to it?
This is -1 times the logarithm.
Okay.
So I'm getting rid of -1. That -1 doesn't have anything to do with what's in here. All right. Now, my logarithm is alone. Now I can loop-de-loop. The base is 10. So 10 to the -2 equals x plus 1. Is everybody okay with that? And of course, what's 10 to the -2? 1 over 100. So now I have to subtract 1. So 1 over 100 minus 1 will be -99 over 100. That's exactly right. Remember, 1 is 100 over 100. So 1 minus 100 is -99. That's exactly right. Nicely done. Good job. That was a good warm-up problem. So is D, actually. Now, what's a little bit different about D, though? What did you say? There's 2 logarithms. Okay, guys, not allowed. Can't have 2 logarithms on the same side of an equation. So we got to put these 2 together so there's only one of them. Because as soon as there's only one of them, then I can loop-de-loop. Can't loop-de-loop with this mess. So we got to put those 2 together. Now, who remembers your properties of logarithms? When I put them together, if it's an add, it becomes a multiply. And then I'm going to multiply them together. Yep, that's exactly right. So I'm going to put these 2 together, and they're going to go together as a multiply. When you combine 2 logarithms into one, you're either going to combine them as a times or as a divide. Those are your only options. If it's an add, they go together as a multiply, so it's going to be x squared minus 3x. If it's a minus here, if it's a subtract, they'll go together as a division, x over x minus 3. You can't have 2. You have to put them together. They're either going to be added or subtracted. If they're added, put them together by multiplying. If they're subtracted, put them together by dividing. Okay. Now what? 10 to the first equals x squared minus 3x. Ooh, what kind of an equation is that? That's quadratic, so I'm going to get it set equal to 0. And then I'm either going to quadratic formula or factor, right? And I think this one does factor pretty easily, but you could always use the formula. I'm going to get a couple of answers. What are my answers? 5 and negative 2. Now I want you to be careful. We talked about this a while ago. I want you to look back at the original problem. Can you put a negative 2 here in place of this x? Can you take the log of a negative number? No. Try it on your calculator if you don't believe me. You can't hit log negative 2. It will say error. You can't take the logarithm of a negative. So this answer is extraneous. It doesn't work. You cannot take the logarithm of a negative number. Oh my goodness, look at E. What do you think you're going to do first on E in E?
Log 7 to log 3.
So Jake says, let's put these two together into one logarithm. Now, the right side over here is fine. There's only one over there. You're allowed to have one. You just can't have two. So he says we're going to put these together and it's going to be 2x over 3. Do you agree with that? Now, over here, after we did that, we loop-de-looped. Can you see that's not going to work here? You're not going to loop-de-loop this. It has logs on both sides. But it's even easier. Because if the log of this equals the log of this, doesn't it make sense that those two things equal each other? Now, some people say I drop the logs. That's fine. You can drop the logs. But when can you drop them? When you have one on each side. And the bases have to be the same. Yeah. Obviously, Kara, none of the stuff I'm doing is going to work if these numbers aren't the same. I will give them to you the same, so don't worry about that. The bases do need to be the same. Log equals log, drop them. Do not drop them back in the beginning. You can't just take away the logarithms. You can't do that. You can only do that when you have one log equal to one log. All right, so what's my answer? Looks like 15 halves or 7.5. We okay with that? Beautiful, beautiful, beautiful. Well, would you try the last one on your own, F? Anya, what'd you do first?
First I combined the two logarithms on the right side. I mean the left.
And made that what? Log what?
Log 4x.
Yep, you multiplied them. That's exactly what you should have done. Did everybody do that? Did everybody combine these two as a multiply? Now we have log equal to log. 4x equals x minus 2. 3x equals negative 2. X equals negative 2/3. Can I do that? No, you can't. Okay, I need to make sure you understand this. I don't just throw out negative numbers. I throw them out if when I put them back in, it means taking the logarithm of a negative. So if this had been x plus 5 here, then negative 2/3 would be okay. But since it's a plain x, negative 2/3 isn't okay. So the answer to this problem is no answer, no solution. You cannot take the logarithm of a negative. All right. Problems G and I are insane. So we're gonna hold off on those. We're gonna do the ones we know how to do, and then we'll tackle G and I. Those are wacky. You can do them, but they're wacky. H, we've already done something similar to this, so I wanna start with this one. Looks like I did some erasing, so I'm gonna make sure 400, 1 plus 95. Yeah. We actually have done these. Does anybody remember how to get started on it? Katie?
Would you have to get it all on one side first?
Well, sort of. I'd like to get rid of the fraction. So I think I'll take this guy right here and multiply him over to here. So I'm gonna leave my 400 here for the time being. Right now I'm gonna have 150 times 1 plus 95 e to the negative 0.6x. So I'm using my calculator to help me here. So distributing, I get 150 plus 14,250 e to the negative 0.6x. All right, let's make sure everybody is with us to this point. Everybody okay to hear? All right, so take a look at it now, where we are now. What kind of makes sense to do now? Subtract 150, so 250 equals 14250 e to the negative 0.6x. Okay, make sure you're with us to this point. What do you think now? Nyla? Divide by this guy? Now, I don't know if it's gonna go in or not, let me check. No, it doesn't. So I don't want to round off, so I'm just going to leave it. I can cross off a 0. I'm just going to leave it 25 over 1425. Seems like that should go in. It sure doesn't. Okay. All right. Equals e to the negative 0.6x. ln both sides. So ln 25 over 1425 equals, what happens over here when I have this ln and this e?
Just like 0.6x.
Just negative 0.6x. So then x, which is the answer, what I'm looking for, will end up being ln that fraction divided by negative 0.6. Would you agree with that? And then rounding that off randomly, I got 6.7384.
Will someone just grab a quick small?
Now, what did I tell you?
Is it not 3, whatever this is, 0.5?
Okay, I said the quiz we take tomorrow, no, it's not, it's 3-1 to 3-4. But we did do some of these earlier, but it's a no calculator quiz,
Oh,
so I can't really give you something like this. So, I've never lied to you before. If I tell you the problems on tomorrow's quiz are gonna be like the ones we practiced, then that's what you're gonna have, right? Unless it's a bonus situation or something. Okay? So I don't know what your other sneaky teachers do, but it's the quiz you take tomorrow is gonna be like the one we practiced today. All right, everybody get this answer? Okay, I want you to take a minute with your neighbor and do the next one. It is very, very similar. And that's J. Do J. We're doing J now.
Where is x minus -0.6 go? Where does x from -0.6 go? Like its exponent?
I divided this up. That's how this got there, to get X by itself. Alright, so take a minute, see how far you can get with this before we tackle letter G. So what you got, Lauren? Emma, you guys got that? I got negative 9.3780, and so did some of the other guys out here, so I think it's right.
Yes.
We have a question from someone about something. You all good? Alright, last chance, I gotta erase this now to get ready for this next guy. He's a doozy. Alright, this is G. The first step, I think, is very obvious. At least I hope it is to you. What do you think? This is letter G. What do you think might be the first step? Multiply by 3. I think that makes a lot of sense. Now, this next step, I think also makes sense because we know that we aren't supposed to have negative exponents, right? What does this mean? 2 to the negative x. What does that mean? 1 over 2 to the x. Now, our first step, we times by 3 to get rid of the fraction that we had. But now we have put another fraction into the problem by dealing with this. So now I have to get rid of that. So I'm going to multiply everything by 2 to the x to get rid of the fraction. When you multiply something times itself, like this, or 2 to a power times 2 to a power, don't we add the exponents? So So this is gonna be 2 to the 2x minus 1 equals 12 times 2 to the x. Now remember, you can't combine these. No 24.
Yeah.
Nope, stop and think. When you do x to the 5th times x to the 3rd, what do you tell me the answer is? X to the 8th. Add the exponents. Does the base change?
Nope.
Don't make it x squared. Don't change the base. It stays the same. So whether it's a number or a letter, the base doesn't change. You just add the exponents. Okay, here they canceled. That's why we did it. And again, do not multiply those. They have to stay like that. Meg, is your hand up?
Kind of. I know that's not a difficult
Are you
answer.
saying something?
Well, I was gonna ask, like, this is like a step ahead, but like, could you divide that 2x that's multiplying, like, you're multiplying yourself times 2x, could you divide that out, like? or
But
do
if you
find-
divide it, you're gonna be right back to what you started with, because remember, that's what we had at the beginning, right?
Yeah,
So, yes, absolutely you can, but it won't accomplish anything.
it'll just go in circles.
Yep. Okay, so now I wanna look at what I have here, because this is where things get a little bit, different. I'm gonna go ahead and get my equation set equal to 0. So I just subtracted this over. Now, I need you to think outside the box here a minute. These two, this is 2 times x, right? X plus x was 2x. And 2x is exactly the same as x2. Now, we never write it that way, but this would be the same as this. Now, I know what you're thinking. You're thinking, why is she doing this? Just hang on. This is a hard problem. This is like 2 to the x squared. I multiply those exponents, I get 2x. It's 2 to the x squared. So I'm going to do what we refer to as a U substitution. We do it all the time in calculus. U substitution. There's even sections in textbooks are called U substitution. If we let U be 2 to the x, then what does our equation say? U squared minus 12u minus 1. So instead of having this horribly complicated looking equation full of 2 to the x's, I said, let's give 2 to the x another name. Let's call it u. So instead of 2 to the x squared, now I can think of it as u squared. Minus 12 u's minus 1. Now, why did I want to do that? What kind of equation is that? That's solvable. You can solve that equation. That's easy, right? Now, it doesn't factor, so I'm going to have to use the quadratic formula, but I'll go ahead and do that. So, u equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I am going to let you, encourage you to go ahead and get decimals for those two answers. Because as much as I want to be done, we aren't done. We have more to do. So, I'm going to, does my quadratic look okay, everybody? The formula look okay? So now I'm going to type it in on my calculator. 12 plus the square root of 148 equals, divided by 2, I got 12.0828. And then 12 minus the square root of 148 equals, divided by 2, I got negative 0.0828. stand for? 2 to the x. So 2 to the x equals 12.0828, and 2 to the x equals negative 0.0828. So now I do my unsubstituting. I've solved, I know what u is. There wasn't even a u in the original problem though, guys, so I gotta get rid of the u. U is 2 to the x. So 2 to the x equals that, or 2 to the x equals this. Well, how do I solve something like that now? This is why it's in this chapter. I need to take the logarithm of both sides. So now I'll log both sides. I'll pull my exponent out in front. And divide. So the log of 12.0828 over the log of 2, and that's my first actual answer. Log 12.0828, close parentheses, divided by log 2, 3.59.
You have to find the correct way.
Now I'm going to do this one. But, Jake, think about it. When I take the logarithm of both sides, whoa, 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 whoa. Is that doable? No answer from that one.
It's gonna be like that every time.
Nope. Nope, nope, nope. It's not going to be. So you gotta, if it's negative, I mean, you can't do it if there's a negative. But you could get two positive answers. Wow. Are we not impressed with our brilliance? Here's the good news. We have one more of those to do.